Section 5.2, example 10, writing repeating decimals as fractions of integers. So use a geometric series to write 3.26 repeating as a fraction of integers. Okay, so then we could find the sum, but before we do that, let's see. All right, so what we're looking at is 3.26 26. So just so we could see the pattern. So what I'm going to say, this is equal to 3 plus, so if we have like 0.1, that's like 1 over 10. That's how we find that number. So if we have 0.01, that's 1 over 100, because this is in the hundredths place. That's the hundredths place. So this first one is going to be 26 over 100. The next one, looking at this, so ignoring this part, looking at just this one, 0.0026. There we go. 0026. We're in the tenths, hundredths, thousandths, 10,000ths. So that's going to be 26 over 10,000 plus 26 over, this time instead of 4 zeros, it's 6 zeros for 1 million. And the next one, instead of 6 zeros, it's 8 zeros. 1, 2, 3, 4, 5, 6, 7, 8. So 100 million. And we could keep on going. So looking at the pattern, we have 3 plus, I'm going to say 26 over 100 plus 26 over 100 squared, 100 cubed, 26 over 100 to the power 4. All right, so 4 copies of this, which would mean 8 zeros, which is what we have here. All right, I feel really confident with this interval here. So I think we're ready to throw this in our infinite sum. So I'll say that this is 3 plus the sum of, or the sum as n goes from 1 to infinity. And we'll call this 1 over 100n, or 26 over 100n. So for the first term, 26 over 100. For the second term, 26 over 100 squared, or 10,000. All right, I feel good about it. All right, so now looking at this, we could use this to help us find our first term. So 3 plus, I kind of just saw something. If we pull 1 out, so that's 26 over 100 times 1 over 100 to the n minus 1. We have our first term, and the first term here, whenever we plug 1 in, this whole thing goes to 0. So this ends up being our first term. I think it'll make it a little bit easier if we write it that way. So 3 plus, here our infinite sum, because 1 over 100 is less than 1. We could use our geometric series, or infinite geometric series sum. So a sub n, 26 over 100 over 1 minus 1 over 100. All right, we have 3. Let's multiply both top and bottom by 100. That way things could divide out. And look at that, this divides out with this one. And then we have 100 minus 1 over 26. We could rationalize this. 3 times 99 is 297 over 99. So that way we could add 26 over 99. And adding those two together, we get 323 over 99. And there we go. That's our infinite sum. Just to show how nerdy I am, I really want to add these two together, or not add them, but like divide them. So when we throw this into the calculator, it should give us this repeating decimal. So 323 divided by 99. Oh, wow. It's exactly what we have here. We did it. All right. If you have any questions, please feel free to ask. Otherwise, bye.